Welcome to the Boeing 777 Auxiliary Power Unit series. The APU is a small gas turbine engine in the aircraft's tail cone. The auxiliary engine supplies electric and pneumatic power to operate the aircraft independently on the ground, start the main engines, and provide backup power during flight emergencies. In this extensive series, we will understand the functioning of the APU engine and its critical role in successful aircraft operations. Let's begin by starting the APU. With no engines running and no external power connected, the only available power sources are the two aircraft batteries. The main battery supplies DC power to the electrical load management system. Selecting the main battery switch closes the contactors inside the panel and energizes the DC battery bus. Now we can select the APU switch. The load management system activates multiple components when the switch is moved to the on position. A signal is sent to the APU fuel pump to run, and the APU fuel feed valve is commanded to open. The APU controller is powered on, and the APU air inlet door is operated. The air inlet system has an electric actuator that moves the door to the open position. The APU controller controls and monitors the start procedure. When the start signal is given through the APU switch, the controller selects the available crank option. Since the aircraft's pneumatic power is unavailable, the controller will switch to an electric start. The APU electric start system has a dedicated battery. The battery is connected to the APU power distribution panel. The controller closes the contactors inside the panel and operates the electric starter. The electric starter is a DC motor installed on the front side of the APU. The battery power operates the starter, which is connected to a ratchet wheel. The ratchet drives a pull clutch mechanism. The clutch transmits the torque to the drive gear. The driver turns the accessory gearbox. Connected to the gearbox is the engine shaft. Mounted on the shaft are the two-stage centrifugal compressors. The compressor's rotation creates suction and draws air through the inlet duct. A single-stage compressor consists of an impeller and a diffuser. The impeller accelerates the airflow radially. The diffuser increases the pressure and directs the airflow into the next stage. The airflow enters the second-stage compressor, which further increases the pressure. The compressed airflow then heads for combustion. The APU feed line supplies fuel from the wing tank to the fuel cluster on the accessory gearbox. The fuel cluster comprises a mechanical pump, valves, filter, and distribution manifold. When the engine reaches 7% RPM, the controller commands the fuel shutoff valve to open. The fuel travels through the primary manifold and into the 14 fuel nozzles across the combustion chamber. As the fuel nozzles atomize and inject the fuel into the combustor, compressed airflow enters through the swirlers. The swirlers twist the airflow, which results in a thorough fuel-air mixture and ensures efficient combustion. At 7% engine RPM, the controller also activates the ignition system. It sends 28-volt DC power to the ignition unit. The unit converts the power into high-voltage pulses and transfers it through the ignition lead to the two igniter plugs. The high-voltage pulse generates a spark in the igniter plugs. The spark ignites the fuel-air mixture and sets off the combustion. The APU engine has a reverse-flow annular combustion chamber. The peak temperature inside the section can reach 2,000 degrees Celsius. Therefore, a significant portion of the compressor's airflow is used to cool the combustor. The combustion chamber is intricately designed with holes throughout the casing that allow airflow injection. The additional flow protects the combustor liner, improves combustion efficiency, stabilizes the flame, and reduces the temperature of the gas before it hits the turbine blades. The combustion gas then flows into the turbine section. The engine has a 3-stage axial flow turbine. A single stage consists of a stator and a rotor. The stator directs the flow towards the rotor blades. The rotor harnesses the kinetic energy of the combustion gas and drives up the engine speed. The flow then passes through the exhaust duct and exits the aircraft from the left side of the tail cone. The combustion inside the chamber, once ignited, is self-sustaining. To prevent flame-out and uncontrolled shutdown during the start process, the ignition system remains active until the engine reaches half its rated speed. The controller then switches off the ignition unit. At 50% RPM, the controller opens the contactors in the power panel and breaks the supply to the electric starter. As the motor rotation stops, the pawl clutch disengages from the ratchet, and the starter is isolated from the gearbox rotation. The fuel pressure in the pump increases with the increase in engine speed. Around 50% RPM, the pressure causes an internal flow divider valve to open. Additional fuel travels through the secondary fuel manifold, and the fuel flow into the combustion chamber increases. The engine accelerates to reach the rated speed. When the engine is close to 100% RPM, the APU's electric and pneumatic power are available for selection. In the next part of the series, we will operate the aircraft systems and start the main engines using the APU power. Thanks for watching.